So in this tutorial we're going to go over multiple regression, and we're going to be using Excel. So the first thing that we look at is our column headings. So we see that we have student ID, GMAT, undergrad GPA, and so on. And in this case we're going to be trying to predict MBA GPA. So MBA GPA is going to be Y. And basically everything else is going to be X, excluding student ID, because that is just a running count of our data. So it goes 401 to 504, or 5,400. So if we want, we can actually get rid of that, because we're not using it. So the first thing that you should see is that there is some letter data in a few columns. In regression, in the multiple regression pact that we have on Excel, it doesn't like that. So the first thing that we're going to do to try to convert these is we can do it one of two ways. We can either put like 0, 0, 0, 1, so 0 would be no and 1 would be yes, or we can do it a simpler, easier way, because we don't want to have to do that for 104 columns. So if we just do equals if in like a random column next to it. So if this cell equals, let's say, yes, then we want to input a 1 because it's the value if it's true. If not, we're going to put a 0, so value if false. And we can just close that off. So you can see that the first one's no, and the third one is yes, so it does work out. So if we just copy that all the way down, and then copy that column so that everything is selected, and just copy over. So paste special values, and OK. So you can see that the zeros and ones are inputted, and this column is all 0 because it's still looking for a yes or a no. So we can just delete that column. So we're going to do the same thing for forward student and gender. So if we just do equals if this equals yes, and yes has to be in parentheses, comma 1, comma 0. And for this one we can do equals if, open parenthesis, let's say male is equal to 1, equals male 0. Okay. And let's just copy those down to see if they worked. Okay, so we see that male, 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 so they do work, and yes for foreign students, so they work. So we just copy that all the way down, copy, and we're going to paste special over these two columns. Right there. Okay, so once again we can delete these columns, and we see that it was copied in perfectly, so it's good. So when you have like a yes, no, or a male, female, so there's only like 2 variables in each column, then you only need 1 column. But for the degree, there can be business, English, or accounting. So there's 3 types of what it can be. So we're going to need 2 columns because we need 1 less column than there are variables in that column. So the first thing I like to do is insert a new column. So we can just do degree, let's say business, and then this one will be degree English. Okay, and let's also go back here and be like engineering degree, so let's say yes equals 1, foreign student, let's say yes equals 1 as well, and gender is going to be male equals 1, just so that we know what the 1 and 0s correspond to. So if we just kind of do an if function like we did in the last one, it'll make it a little bit easier. So if we just do equals if So this one's business, so if that equals business, then 1, if not 0. So we're just saying if this is business, put a 1, and it does. So now we do the same thing for this English one, but we're going to be looking at this column. So equals if this same column equals English, comma 1, comma 0. So it's looking at that to see if it's English. So if I just go down until we see accounting, we see that accounting is 0, 0. So it's not English and it's not business, which is why that works out. And we need one less column. So if we just drag that all the way down, copy it, and let's just paste over everything. So paste special and values. And then we can delete these columns. So that's it for trying to get, or getting the data into something that we can actually use. So now, in order to do a multiple regression, we just go data analysis, go down to the regression. So now we're going to input our y's and x's, and I like using labels. So on the regression it shows us what coefficient relates to what. So we'll just use everything. So the y was the MBA GPA and x is everything else. So use labels. And on this I'm going to use a new worksheet. So I'll just label that regression. Sorry. And just hit OK. And then here's our regression. So if we just make this a little bit easier to see by double clicking next to the columns, it puts it in something that's a little bit easier and everything is full. So what I like doing is putting everything down to the 3 decimal places, and except for the ones with the E minus like 14 or some of the other ones. So let's do it with these ones. And you see that there's an E minus 12 right here, so we're gonna have to go around that one. So there's no E minus 12 in there. Down, down, E minus 12, not anywhere around there, okay. Okay, so now this is something that we can actually look at and not be too overwhelmed with the data. So here we see that the adjusted R-square is kind of low, so it's at 0.54. So we may want to try to get that higher. So what we're going to do is look at the p-values in this table right here. So we're going to look at the highest one. So foreign student is the highest p-value. So we're going to look to get rid of that foreign student column from the data because it's not predicting y very clearly. So it's not that good of a variable to have. So what I like to do is just copy everything into a new worksheet. And then I'm just going to get rid of foreign student right after I make that a little bit bigger. So you just go delete, and it gets rid of that. So what we'll need to do this again is just go back to data analysis, down to regression, and everything is kind of pushed over one column. So we just re-input our y's and x's. I'll do regression 1 so it doesn't overwrite the regression that we already have, and then just OK. And I'll just do this for this one. So we're still going to be looking at adjusted R squared. So 0.547, 0.543. So it went up. So we have a better regression right now. So we're going to look at this again, and we're going to keep taking out columns until the adjusted R-squared goes down. So if we look, we see that, and we're not going to be looking at the p-value of the intercept because we can't get rid of the intercept. So we see that the business degree is the next one to take off. So what we would do is go back here, get rid of business degree, and then we're going to rerun the regression. And it actually took everything off, so that's good. So we can just rerun it on regression 2. So 0.535. Go back to regression 1. 0.547. So it's actually worse. So what we do is just, whoops, we would just use regression 1 as the best regression. So some of the things that we are going to use or need to know in this table is adjusted R-squared, standard error, significant of f, the p-values, and the coefficients. And all of these definitions are on the website under chapter 4. So in order to predict, let's say the MBA GPA for any such thing, we can actually delete this. Yes. Go to regression 1, and let's say, let's just move everything over 1 so that's easy to look at. Make that a little bit bigger. So now let's input our x's. So we're going to try to predict for the MBA GPA. Okay, so I'm going to use some product, but I'll show you why this one is a little bit better than doing it out by hand. So let's say they had a GMAT score of 750. They had an undergrad GPA of 3.8. They are 23. They have an engineering degree, so it's not business and it's not English, and they are male. So if we just use some product, we can just highlight this array and this array. So basically what it's going to do is multiply this number times this number and add it to this times this, and so on and so forth. So it predicts that the MBA GPA for a student with these qualifications will be 3.958. So one more thing that we're going to do is do a 95% confidence interval. So there's going to be a lower and upper, and we're going to do it for what we had just predicted. So it is equal to this minus 2 times the standard error, and we find standard error over here to find the lower interval, and if we do the same but plus right here, 2 times the standard error, we get our confidence interval. So our interval is 3.47 to 4.44, and we're 95% sure that it will lie in that boundary. So I hope you found this helpful.